So by way of recap, we went through the basics of the scientific computing and then what the Python itself is. We looked at some basic, some fundamental aspects of it. I mean, starting from comments to inputs, outputs, and some variable, assignments, data types, and then we focus on some specific data types, and we ended with the conditional statement. wrapping it up with the one-liner conditions. And so we would continue with today's session. I believe you can hear me. If if you can, is it possible you just show by hand so I know we are all on the same plane? All right. Okay. Thank you. All right. Okay. So welcome to day two. And for today, what we'll be looking at is we hope that at the end of the session, you should be able to differentiate the various iteration forms. When we talk about iterations, we are referring to sort of cycling or loops, right? So repeating actions or repeating actions. So you would do something and then redo it till a condition is met or a condition is satisfied. And then that whole procedure, that whole process is what we call the iteration or what we call the loop. And so we expect that at the end of today's session, you should be able to differentiate the various iteration types and then be able to apply them. And we should also look at how to, either break out of certain iterations. If not, the iterations would be, continuous. They wouldn't have any stopping criteria. So it's necessary to look at some controls for the iterations, and then we would end it up with, you know, functions. We've been looking at some built-in functions from yesterday when we're dealing with the data types, but today we'll be looking at how to build your own function and then apply them on given data types. Okay. So to start it all off, when we talk of iterations, like I mean, we are looking at repetitions, and basically we know humans do not like repetitions. But then the truth is that's what we would have to do when it comes to programming. If you want to um, maybe perform a certain action on a given set of variables, you would want to loop it through till the action is done. And so it's very necessary we understand the various types of iterations and then how to apply them or which one works, way faster, which one is optimized and which isn't. So think of it this way: as we are going through a whole structure or we are going through a code. Now at this point where we have this rectangular shape, we are supposed to perform an action, and then based on the output it goes to this um, sort of a kite shape, or yeah, that it goes there, and then this is where we would have to repeat the action. So this whole cyclic process, the movement of the arrow shows the flow. So there's a typical flow chart showing the fact that we would have to, take a decision over here. From this shape we take a decision, and then based on that, I mean, we would either go over the step till a stopping criteria is met, then we go out of that um, loop. And so in Python we have two main loop types. We have the while loop and then the for loop, and we can also merge them to have what we call the nested loops. Okay, thank you, David. Is it better, David? Yeah, hello, David. Is it better? Hello, David. Is it better? Okay. All right. Okay. So we will be dealing with the while loop, the for loop, and then also where we'll look at nesting them or merging them to form a set. Okay, thank you. So we can perform a set number of, number of iterations or set number of um, loops or repetitions. So we start off with the while loop, and as the name implies, so we are going to perform, just think of it in normal English terms, we are going to perform a certain action given number of times till the criteria is met. Okay, we are going to perform the action till a certain criteria is met or the criteria is true. And so the syntax is just indicating the keyword while, okay, and then from there would indicate the expression which should be met or the expression that's true, okay, and then from there a given number of actions or statements. And because there's the while loop, we would need to also set an iterator. And just a quick one, I forgot to um, before that. Okay, so just a quick one, sorry. Okay, so we would first have our iterator, and then we are going to perform the while um, loop. And so the keyword while would precede it. And then after that, we'll have the expression to be evaluated. And like I said, for the if condition, is the same for the loops. So beyond this, you'd also have to keep a colon, and that colon indicates that we are working within the colon. The colon indicates that everything that's indented under it is part of that construct or that while loop. Okay, so we indicate that and then we indent all these other statements. So by indenting, we mean we are leaving a certain number of spaces. So we have our statements that should be executed, and then because we set our iterator, we would have to increase the iterator. Other than that, this wouldn't, it would just be stuck at one point and it wouldn't move. So let's think of it this way. So first and foremost, we set our iterator. From yesterday, we saw variable assignment. So let's set our iterator var a variable assignment as say I being equals to I is equal to 0. And then from there we have our keyword while, and we are going to have our criteria or our condition that should be met. So let's say while I is less than 5. That means this whole construct you are going to build should only evaluate as long as I is less than 5. Once I is equal to 5 or above 5, it stops. Okay, so the loop would be continuing as long as the condition we've stated is true. So we have while I is less than 5. Now from there we indicate a colon. That means whatever is going to be indented under it is a part of the construct. Okay, so we have while I less than 5. Let's just print the I so we know what I is. Okay, now think of it this way. If I fail to bring the iterator incrementer, that's the increment was going to increase the iterator. It means our iterator or the I is fixed at 0. It doesn't change. So let's try running this, and you have 0 being printed over and over and over and over again. And this is going to continue. If you look here, there's an asterisk, meaning this cell is still performing an action. And then when you look up here, we have this um, sort of time glass icon, right? Telling us that this notebook is still performing an action. And so if we don't break out of it, it's going to continue. It wouldn't stop because the condition would never be satisfied. I is always going to be 0. Okay, so I'll need to stop this from here. I need to break out of the kernel. So that means increment should be default, by default it should be stated. So we have I, for instance, I equals to I plus 1. Okay, we'll look at this in a different phase. So what this means, like we saw from the variable assignment, whenever I have this, the one on the left hand side is the variable, the one on the right hand side is the value. So if I should have, say, a equals to 0, the variable is a, the value is the 0. So if I print out a, now a receives the value of 0. Okay, now let's think of it this way. If I want to increase a, now I have a equals to a plus 1. That means I'm adding 1 to the value, that's the current value of a. Okay, and then whatever I get should be passed to a new variable a. So over here, this will be replaced by the value, which is in this case 0 plus 1, giving us 1. And then the new variable of a would then be 1. So if I print out the a, we would notice that a changes to 1. If I repeat this, a goes to 2. If I continue, a goes to 3. So it's increasing in steps of 1. All right. And then, so once we understand this, that's exactly what we'll be doing over here to increase the I in steps. So as I is increasing, it would continue printing out till the condition here is met. So if I rerun this, we would have I being 0, 1, 2, 3, 4. And then, bear in mind, because of where the print statement is, we have first I being set to 0. It compares with the criteria. Okay, I is definitely less than 5, 0 is less than 5. So what should it do? Print the I, which is 0. And then from there, increase the I by a step of 1. So I then goes to 1. So the condition wasn't met. I mean, the condition was still met. It's not outside the criteria, so we would still continue till this condition becomes false. So now I is 1. It compares again from here, and the I of 1 is less than 5. So it prints out the I, which is 1, and increases the I to 2. Bear in mind the I being 1 was still condition being met. So now 2 is also less than 5. So it prints the 2, and it increases to 3. 3 is less than 5. It prints increases 4. 4 is less than 5. It prints the 4, and it increases to 5. Now when we compare 5 to 5, 5 is definitely not less than 5. 5 is equal to 5. So this condition now is false, and so the while loop terminates. Imagine if we had this being less than or equal to, then it means we would have I being printed from 0 to 5. Okay, and always know that based on where your execution is, either above or below your iterator, would give you a different output. Now let's look at this other option. Let's redo the same thing here, but this time we are going to have the print statement after the increment, right? And bear in mind, this is part of the while loop because it's indented. It's still indented under the while loop. Now, thinking of this in the way the program is going to execute. First, when I is 0, definitely 0 is less than 5. So then 0 plus 1 becomes 1. That means I changes to a value of 1 before it's printed. So you would not have I of a value of 0 because of the position. Unlike the first one where we printed the I of 0 before we increased. Now in this case, the I would be increased before it's printed. And so we expect that the output would be all these outputs we are having plus 1 because they are always going to be one step higher before they are printed. All right, and that's what we have over here. So you need to understand the dynamics of the the indentation, the while loop. I mean the whole construct. You need to understand them. So I know, okay, once I place this here, this is what the output would be. If if I change it, this is what the output would also be, right? And then what if I forget to indent this, right? Now this means that the print statement here is not so much dependent on the while loop. It would only depend on the while loop based on the final output. So what it would need is it would just pick the final output from the while loop and then print it because it's not indented under the while loop. So it means whatever we are doing here, the values we are seeing, none of them will be echoed. It would only be echoed when the criteria has been met and then the final value we had when the criteria changed from true to false. Okay, that's what will be printed. So it means in this case the final value of 6 is what will be echoed. So indentation plays a key role in your construct and you need to understand that. Okay, so this is one of the ways. Now even the increments we are looking at, there is a rather more simple way of doing that. So think of it this way. We had, let me use this one. So I have a to be 0, and then to increase this we said a should be equal to a plus something. So let's say maybe 1. And we are saying that the one on the left hand side is the variable, the one on the right is the value. So first a has been assigned the value of 0. Over here a would change to the value of 0 because it is the value. The value in here is 0. So 0 plus 1 will give us the variable now assigned a new value of 1. Now what we are doing here can be simplified. So if you've done a bit of, I think this works similar in PHP and then also I think C++. So what you can do is you have you have the A plus equal to 1. Now this just means that we are increasing the A because of the addition symbol. This is the same as having A equals to A plus 1. This just increase the A by a step of 1. Okay? If I had want if I want to decrease it, then it means I'm going to change the plus symbol into say a minus. Alright? And then this would also mean the same as A being equal to A minus 1. And so all the arithmetic would also work. So if I want to probably um, multiply it by a certain factor, I can equally do that by just changing this. Instead of going to do A equals to maybe A times that. Alright, and this means I'm finding the arithmetic of that particular value and writing it back to the same variable name. Alright, and so if we run this, we are going to have, sorry, I need to print the A. We are going to have A now being a value of -1 because first we had A being 0. Now A being the same 0 minus 1, which is -1, and then that's output. So in this place where we increased our I, we can just simply have I plus equals to 1, and that works. Okay, so let me bring the indentation up here. So we still want to print out the output, so this would still give us the same output. Are we okay? Any question before we move on? If there are any questions, we'll take them before we move on, please. Um, so Francis, do you have a question? Hello, Francis. I see your hand up. Please, do you have a question? So if you have a question, just come up to the spotlight area where the podium is in front. Just come stand there and then you can ask it so that the whole class will be able to hear. If not, you can also type it in the chat on the bottom right. Okay. And when you are typing in the chat, if it's something that's meant for the entire class, make sure it's set up here to the room. Select the room. And if it's something meant for only the people on your desk, then you can change that to nearby. Or you can also inbox individuals via the inbox approach. All right. So I think we can go on. So that's how the while loop works. So we have, take this example, we have x set to 1, and then we are saying that while the x is less than 6, we should be printing out the x, and then from there we should increase the x in steps of 1. Okay, so this would be printed out as long as x is less than 6. So we would have x values of 1 all the way to 5 because our starting value here was 1. And then bear in mind the print is before the increment, so all the way till 5, then it's done. Now we can also make use of, I think I'll be talking more about these control structures again, where in this case, for instance, we've set x to 1, and we are saying that while x is less than 8, it should print x is x, right? Now this part is a string, which we saw yesterday, so this will be printed the way it is, x is, and then from here the value of x will be echoed. And we are saying that the x should be increased within this while part, or within this part where this criteria is true or is met. And then the alternative is that, which we remember this from the decision making we did yesterday with the if statement. So the else part means, okay, once we go out of this loop into the alternative criteria, we should also print out that, okay, now this string x is no longer less than 8. So if I should run this, we have x starting from 1. So first step, when x is 1, 1 is definitely less than 8. So we would have this printed out, which is x is 1. That's the first part. Then the x gets increased. Okay. Now x changes from 1 to 2. Bear in mind, when x was 1, this condition was true, so it has to go back and reevaluate the new x. So the x at 2 is reevaluated, 2 is less than 8, so this will also be echoed, so x is 2. And it would continue evaluating and printing out as long as the criteria is true. So this would continue till we have x being 7. When we have 7 here as x, 7 is definitely less than 8, so this would be printed, and then it would increase x to 8. Now if x is 8, this criteria is not met, so this wouldn't be printed. The while loop would terminate. But then the alternative is, for any other extra condition, it should print out x is no longer less than 8. So when x was 8, we had it echoing out x is no longer x is no longer less than 8. And so that's how the while loop works. So we have a trial example here. So let's say um, the question says, so using the while loop, find the equivalence of the degree Celsius values of C, okay, where we have our temperature ranging from 10, that's, I mean, greater than 10 and less than 70 in Fahrenheit. Okay, so we are finding the equivalence of the degree Celsius values in Fahrenheit, so meaning we are going to change from degree Celsius to Fahrenheit for this range of values. We are saying that for each C, print its corresponding value in F. And then the we've been given the formula, and then also we are told that we need to do this in ranges of, you know, 5, or in steps of 5. So what we need to do first is to set our original C value. Okay, so I mean, these are temperatures, so let's call that, say, T. So T underscore C, that's a T in Celsius. And we said this should be, I mean, from 10 all the way up, so definitely this is greater than 10, because 10 is less than the C. So let's start from probably, say, 11. Okay, and we have our while statement. So the while loop, the keyword comes while this T underscore C is less than 70. That means this should be performed all the way till the moment we get to 70 or beyond, it should stop. Okay, so while this T underscore C is less than 70, we are going to perform a certain action here. All right, so we'll come back to the action, and then we are going to increase the T underscore C by an interval of 5. So it means we are having this TC plus equal to 5. That means TC underscore, I mean the T underscore C, when it's sort of evaluated, should increase in steps of 5, and it will be evaluated in these steps till it goes beyond. All right, so now we come back to our action. Now our action is to just perform this, and so we are going to find T underscore F, which is the temperature in Fahrenheit, and we equate this to this 9C. Bear in mind, if I just write this 9C, this will produce an error. Okay, and this is actually one of the commonest errors that you see programmers making, because we evaluate this in our minds as though, okay, the PC is also a human being, but I mean, the PC doesn't understand this. So this is 9 times C, so you definitely need to bring in here the star, which is the 9 star C. All right, and then we are going to divide by 5. Now bear in mind, Python works on this Pemdas approach. Okay, so if there's parentheses, it would evaluate that first, then followed by the exponential, then the multiplication, before division, then addition, and then subtraction. So if I have this 9 star C, say that over 5, now this is going to evaluate this part first. It would multiply the 9 by the C before dividing by 5. And this is exactly what we want. Okay, so we wouldn't have an issue at all. But to also be on the safer side, you can just put this in a parenthesis so that you are sure that it's going to multiply the 9 by the C before dividing by the 5. Okay, and then when you're done, it's going to add everything to the 32. Now in this case, if we had not brought the parentheses, this will still work the way we want it to work, because the multiplication would definitely be evaluated first, followed by the division like we are having here before the addition. So we wouldn't have any issue with this. But to be on the safer side, we just put this in one parenthesis, and then from there we can also decide to put this part in another parenthesis, so that we know that, okay, this is evaluated first and then it's divided before it's added to the 32. Okay, and then we are told to print for each C, we are printing the corresponding value of the F also. So we can just echo here. So let's print, and then we bring in here maybe a string. So the Fahrenheit equivalence of, then we bring the temperature in Celsius value. So degree Celsius is, then we bring the T underscore F. So all we are saying is that this should print out the Fahrenheit equivalence of the value that we give in degrees Celsius, with degrees Celsius as a string, is, then it gives the Fahrenheit value. So if we print this out, oh yeah, sorry, I forgot we were using T underscore C. So this part. So instead of the 9 times C, bear in mind we use T underscore C. So that should be what we call in here. All right. So it gives us from 11 all the way to the closest value that's lesser than 70. So it says the equivalence of 11 is this in Fahrenheit, this is that, all the way till the final value, right, which we can evaluate. Now, we saw some string formatting yesterday, so we can equally apply that here. So rather than printing this whole thing, we could just have the same statement, and wherever we would need this, we can pass in here just the curly brackets. Okay, and we said, so in this case we are going to pass here a value, we are going to pass here also another value. Let me comment the very first one so we know it's not functional, and then we would indicate what values to pass by formatting. So if we format them, means we can just pass the values here as T underscore C, T underscore F, and this should work the same way. All right, and also you can, like we saw from yesterday, you can just just explain these ones maybe. Sorry, so let's say there's a cell being the Celsius value, and then maybe far being the Fahrenheit value, and so we will then pass in here the labels. Okay, and this also works. Okay, and like we said, once you indicate the labels, it means it's dependent on the label, so I can decide to change the labels at any time, and that would, you see, so in this case it will be based on the label I'm using. Okay, all right, so I think so there's also another explanation of the same thing that we did up there. Yeah, I think this should be from 11 from here. Yeah, so that's it. And then we have another example, and we are trying as much as possible to use very simplistic examples so that it's easy to understand. So we are going to use the same while loop, but this time we are going to use that with a combination of the conditional statements, that's the if statement, and then we are going to print out all prime numbers lesser than a given number. So I'm going to just explain what we did in here, and I hope it will be quite easy to understand. So we are saying first we will need to have a given number. All right, so we are requesting a number from the user, making use of the input method. So if you remember from yesterday, we said if I have this input statement, it means this would request an input from the user, and then whatever we are having here as a string will be printed out for the user to know exactly what to pass in as a value. And we said the value that would be read by input is by default a string. So if I run this line, it's requesting an input. It says enter a whole number. So let's say 5. Now the 5 we are having is a string, but I want to treat this as a number, so I would need to convert this into an integer. because I'm dealing with integers here. So I make use of the int method. And so think of this way. If I have int into bracket and say I pass in 2, 3 as a string, this will be changed to an integer value of 23. Okay. All right. So that's exactly what the very top part is doing. So it requests an input from the user requesting a whole number, and then it would convert that whole number because it's a string. It will convert it from a string to an integer and assign it to the variable value. So if we print out the value, we should expect to have what the user entered, but as an integer. And then we all know that prime numbers, definitely are numbers that have two factors. That's itself and then one. And prime numbers definitely will start from 2 and beyond. So once we know that, we know where to start our while loop from. So I then indicate an iterator, say n. So now n is equal to 2. That means our starting point in this case will be 2. All right. And then we have here, so prime numbers between 1 and then whatever value the user entered. Now in this case, because we've already converted the value into, we've converted the value here into an integer, I want to bring that back as a string and then concatenate it. So that I made use of the plus sign. But from what we saw yesterday, it's also possible, which we've seen again today, we just can pass here curly brackets and then add the format and indicate just here value, and that will just be added. Okay, so both ways would work. Okay, so let's keep the other one here so at least you can use that for a reference. All right, now we have our keyword, which is a while, and then we have our criteria. We are saying that while the n is less or equal to the value, because we are going to print out all the prime numbers that are from 2 all the way to the number the user entered. So our condition here is that as long as the n is less than or equal to the value. Now, what we did in here was to also use sort of a nested loop. Okay, we did a nested loop by reassigning a new value of m. So m here is now equal to 2, and then we just assigned a count, something just to keep counting, you know, certain certain things for us. So we are going to have the count value increasing based on some criteria we set.
Yeah, hello.
Yes, please.
Please, I think you said while and like you are printing the uh, prime numbers between one and the number given. So I think the first this one should be less than, but it shouldn't be less than or equal to the value. Because if you make it less than or equal to value, you are including that value to it.
Yes. Okay. So I think maybe the question is not coined right. So okay, yes. So I mean, we are printing all prime numbers lesser than a given number. Yes, exactly, exactly, exactly. So if it's inclusive, uh, so if you could move from the spotlight, I think there's some noise from your background. Yeah. So I think that's exactly it. Sorry. Thanks for prompting me. Okay. So it means our n definitely should be less than the value because you're looking at prime numbers lesser than the given value. Okay. And then from there we have we just set another criteria of m being 2 and then just a counter to keep count of certain conditions. I mean, certain increments based on some conditions. Now, in this case, what we are saying is that we are looking at the m being less or equal to n, floor division of 2. Okay. Now, is this, if I am dealing with a prime number, then it means if I have, say, a huge number, halfway through the number, I should be able to tell if the number is a prime number or not. Okay, just a quick one. So, Gesh, I think you are doing something wrong. You don't need a semicolon, you need a colon instead. Okay, so it should be a colon, not a semicolon. Right. All right. Okay, so halfway through the number, you should be able to tell, because if half of the number, I mean, none of them has been able to divide it, then you don't need to go all the way up. So that's why we had to set this um, sort of nested loop to do a halfway comparison. And so from there, we say from here that whatever our n value is at any point in time, whatever the n value is, we should divide, it should find the modulus of that n by the m, because this iterator is then going to give us, um, numbers that are, I mean, less or equal to halfway the value. So if the modulus of that, the n that we are at, okay, divided by, I mean, numbers lesser or equal to halfway its value is equal to 0, then it means that number has been, is actually divisible by a factor, and so that cannot be a prime number. So once that happens, so we have the count increased, all right, and then we can also then look at our increment of the m so that the m wouldn't be static, and then we have here to print the n if the count is equal to 0. We saw this yesterday from the decision making, the one liner decision making. Now this will be only evaluated if the criteria is true, and so we are saying that once the count goes beyond 0, it's no longer a prime number, because we only set this here as 0 as initial. Once there's anything divisible, it means the count would increase, so we don't need to even print that out. So we print only the prime numbers as long as the count is 0. Other than that, we don't print anything, just a blank. And then we would also have to increase the iterator n so that the n is not static. And so if we evaluate this, let's say we pass in the value 5, okay, and we enter. Now it tells us that we are looking at prime numbers between 1 and 5, and then the values here are what, 2 and 3, and those are actually the prime numbers between 1 and 5. If we should test that on a bigger value, say 100, then we can see the set of prime numbers between 1 and then 100. Okay, and I mean, if you run through, you would actually see none of these are non-prime numbers. I mean, they are all prime numbers. Okay, so this classical example, classical use case, which you can test the while loop. Okay, so if there's any question on the while loop, we would address that quickly before we move on to the next one. Any question? Then, Quigren, do you have any question from the other end?
Um, I don't have any question from any other end now. So
Okay, all right. And there's also no question from the streamed video, so we can go ahead.
yeah.
Okay, all right. All right, so the next item is the for loop. And one thing we can know from the while loop is that when you start, you don't know the number of times you are going to iterate, okay? Because it's dependent on the criteria. Okay, so I think, yeah, so maybe that will be better after the class, Emanuela. Okay, all right, so one thing that we need to understand for the while loop is that it is based on the condition. So as long as the condition is true, the loop would be continuous. It would just continue performing that set of actions. So you might not know exactly how many times it's going to be iterated, especially when you have a very huge data set, because it's based on the condition being true. So you are not so certain on the number of steps or the number of iterations to be performed. But then for a for loop, you can actually tell because it's based on a definite number of elements. And so once we can find the length of the elements, we know the number of times the iteration would be performed. All right. So the nature of for loops, like we said, is that it would allow you to iterate over a certain sequence, and this sequence can be anything. It can be starting from a string, a list, any of the data types we saw yesterday. All right. So and the construct is this. The syntax for the for loop is simply you have the for keyword, okay, and then you have your iterator. So for the iterator in a given sequence, then after that we have the colon, we would indent, and then we would have a certain action, right? Over here, we don't need an increment in the iterator because the iterator is dependent on the sequence. So it's only picking from the sequence we already have. And that's all. Okay. Okay. So that's typically how the for loop looks like. We have the for statement, the iterator in the sequence, and then the action. And then, like I said, once you have the colon, you know everything that's indented falls under that construct. Okay, so let's take this example. We have the variable language, and then the language is a string that contains Python programming. Okay, and bear in mind all these elements have their individual positions or their indices. And so if I have my for statement or the for keyword, and then the iterator here being L, I'm saying for L in the sequence language we have. Okay, then from there the colon, and then I have my indentation. It should print out the L. It should print. So whilst L is going through this sequence, wherever L gets to, whatever value L will be assigned to, it should just print that out. So we have this print statement. So it starts from first L being P, and it's printed. It moves on to L being Y, it's printed, on and on till the space, and then all through till the programming, till the end. All right. So this is the iterator dependent on the sequence. So we don't have sort of any stopping criteria sort of thing. Now the criteria to stop here is just dependent on your the sequence you've defined, and that's how simply the for loop works. Now, like we saw yesterday, I can equally, subset this. Let's say because I'm able to subset a string, so let's say we have this all the way to 6. We want just the Python to be executed, right? So now the sequence is not the entire language, but the sequence in this case would be the subset of the language. So this whole part becomes the sequence. That's the subset of the language. And that's what we are going to then iterate over. Okay, so we can do an iteration over a string. We can also do same over a list. Now we have this list. And you remember from yesterday we said a list is always identified by the square brackets. So if I've defined this list as say animals and I have dog, goat, cats, fish, and then my keyword, which is the for keyword, then the iterator, in this case say A. And there's also another keyword here which is in. So for A in the list of animals, that's a sequence animals, and then the colon. I just indent and then print the iterator. Okay, and that's all. Okay, now we can also do same using ranges. So if I have a range, now think of it this way: whenever I have a range, I should have a starting point. So let's say 1, a stopping point, say maybe 5, and I can have a step. Okay, say 2. Now when I just type range, this will tell me there's just a range of values from 1 to 5 with a step 2. Okay, it doesn't show individually the elements, but there's also, we can also use np.arange in NumPy. We'll be looking at all those importing of packages tomorrow, and so that's cool. But this is only telling us that there's a range of items starting from 1, or numbers starting from 1 to 5 with a step of 2. Now if I decide to print all the individual elements, then it means I can do that from here. So if you have, in this case, say for x in the range of 1 to 5 with steps of 2, we are expecting it to print 1 inclusive, then what's the name, 1, 3, and then on and on, as long as the criteria is right. Okay, so we have 1 and 3, and the question is, so why didn't 5 get included? And this I explained yesterday. We said is the same as we did over here when I was looking at the languages, say from 0 all the way to 6. Okay, Now, by default, it's always going to be, the final step is always going to be n minus 1 that. Okay, so we have the same thing. So if this is 5, it's going to stop at, actually the criteria will end at 4. If you had to print in steps of 1, you notice it starts from 1 all the way to 4. But 4 is not within that range if we decide to use steps of 2. Okay, so that's why we have just 1 and 3. And we can also try same here. And this prints out 0 to 4. Now, by just passing in a single value, it means this is treated as the ending point or the ending value. The starting value is then assigned the default index. All right, and then the stopping value is then treated as what we have here. The step is by default 1. So if I print out this, it's going to start from 0 all the way to n minus 1, which is 4. Okay, and that's it. Now, let me just chip in something simple here. The beauty of also the for loop. So let's say I have elements. Let's say this is my sequence. My sequence here is, say we have 1, 2, yes, 5, OneQuantum, PY4CA, we have, say, Ghana, we have 57, let's say we have metadata, any of them. All right, so now we have this sequence. So this is our sequence. So if I print out the sequence, I should see this very same thing. Okay, now what if I just don't want to print out the values? I also want to print out the positions. I mean, we can make use of what we call the enumerate. I think I would update the notebook and then indicate that. We can make use of the enumerate function. Okay, so let's say I have enumerate on this sequence. What enumerate would produce? This will then produce the index and then the item. So when I make use of the enumerate function, it produces an output of the index and then the particular item. So let's say I'm going to make use of the for loop on this enumerate method. So I have here for the seq in, say, enumerate sequence. Okay. Now, because we said this is going to produce an index and then the item, if I should just run this, this will be producing sort of an error because it's expecting 2 elements to be the iterator, one for the index, one for the item. Okay, so let me just pass here an index before the sequence. That means whilst we are looping through this, because we are making use of the enumerate function, it should assign the indices of the various sequence items to the index and then also assign the values from the sequence themselves to the seq. Alright, and so we decide to print the index and then also the sequence, and then we can see. So this gives us the elements or the items themselves on the right and then their individual indices. Okay, telling us the 1 is at position 0, 2 is at position 1, 3, the years at position 2, and so on and so forth. Okay, so this, I had to chip this in because this will also come in handy when we start looking at, bigger scale computation and all that. These are very, very simple, subtle things, but if you know how to use them, they make your programming quite easy and very seamless. Okay. All right. So there's this exercise here. So what we did with the prime numbers using the while loop. There's also a task here for you to use the for loop to try and then reproduce that. So I'll leave this for you so that you can try your hands on it, and then hopefully, if we meet tomorrow, maybe one of you can share what you've done with us. Okay. And then we've also already seen the nested loop, but we'll just go through it again. So when we say you are nesting something, just think of it as a web. So we have one being a sub of the other in that same order. So they are all woven together. So whenever you have a nested loop, always think of it this way. The outer one is evaluated first, and then the inner ones within that. Okay, so if I have the outer one, it starts with the first let's say the first iteration of the outer one, and then it will produce all the inner iterations of that first iteration of the outer one. And then when it's done, it will move out again, pick the outer one, evaluate all the inner ones of it, and in that same order. So over here, let's say we have A being a list of 1 all the way to 10, and then B is also a list but contains just the value 5. And then we are making use of the keyword. We say here for A in the uppercase A, followed by for A in uppercase A, followed by the colon. We are then going to have another loop. Bear in mind, we said after the colon always there should be an indentation. Okay, so even though this another loop, it had to be indented within this loop because it's a nested loop. So we had to indent this one also within it. And then from there, whatever came under the second loop is also indented within the second loop because the colon tells us that we need to have that structure. And then we then printed out this output for all the inner loops. So we are saying that when we start with the A value, let's say the first one, we move on to the B. For all the values of B under the first value of A, we produce all these items, and then when we are done, we come out. So until we are done with the B, we come out, pick the next A, go back to the B again, produce all the same things, come back to the A until all the A criteria is met and all the B's are met. So let's take the first example. So when A is in A, let's say the first value of A is 1. Now it moves on to the B. B in B, B would always be 5. So A of 1, B of 5. Then it's going to find the product of the 1 and 5. And Y becomes 5. So we have here the B value, which is the 5, times the A value, which is the 1, equal to the Y value, which is 5. Now it was done with the B, so it has to go back outside to the A because there's no other B, so it goes back to the A. The A in the second part is 2, so it picks the A of 2, comes back to the inner part, and then B is still 5, so we have here Y being the product, which is the 2 times 5, giving us 10. So it prints out the B value of 5 times the A value of 2 being equal to 10. Because we had just one B value, we are done with the inner loop for B. So we go out again and pick the outer one of A. So it's going to continue all throughout till it gets to the end. Now imagine we had the B value being multiple values, say 5 and 3. Then it means it starts from first value of A being 1, and then let me change this so that it can be just the A and the B instead in the order. So it starts from A being 1 and then goes for the first value of B. So A1, B5 finds the product, which is 5, and it prints out 1 times 5 equals to 5. Now, within the inner loop, it's not done. It was only done with the 5. So still maintaining the A value of 1, it picks the second value of the inner loop, which is the 3. Okay, and finds the product of the 1 and 3, and it prints out 1 times 3 being equal to 3. Now it's done with the inner loop, so it goes out for the next outer loop, which is the 2, and comes back to the B again because it's starting the whole procedure. For A being 2, now B being 5, we have 10, so 2 times 5, 10. And it's done with the first B, but there's a second B, so maintaining the A of 2, the next B being 3, it finds the product. So if we should print this out, sorry, that's the upper one. So if we should print this out, we would see maintaining the first value of A, which is 1, and then now the B of 5. When it's done, it still maintains the A because B is not done. It then changes the B to the next value and finds that. Now because we've exhausted the B, it goes back to the next A and then picks the first B, produces that. B is exhausted, maintaining the second A, goes for the next B. Once B is exhausted, it goes out again, and so this is going to continue till all the values are fully dealt with. Okay, and that's how it works. That's how the nested loop typically works. If you have any question, you can still post them in the chat, or you move to the spotlight and ask. All right, while we try looking at this. Now let's look at this other nested loop. We have values of n as a list 2 and 4, m as a list of 3 and 5, o as a list of 1 and 2, and we've indented the first part. We have the the for loop, the first for loop, which is for n in n. So it means we are having lowercase of n being items of the uppercase of n. And then because this colon comes, it means we have to indent whatever is going to be a part of it. We need to have the second loop as a part of it. So we indent the second loop, and we have the lowercase m in the uppercase of m. So that means all the items of m are going to be assigned the iterator one after the other. And we have the colon again. So it means the next step, which is also a sub of the second iteration, should be indented. So now we indent what's here, which is the u, the n, the m, and then the o. All right, and then we print out what we are having, the n, m, o, and then equals to u. Now this produces an error because we don't need an indentation here. Okay, there's another reason why we produce the error, but then the error we are seeing from here is just telling us that we don't need an indentation because this part is not a construct. Okay, you can only identify the construct using the colon. All right, so if I'm going to indent, then everything should be aligned, or the indentation should be in line, but this is not in line with the indentation we are having here, so this produces the error we are seeing. Okay, so if we run this, that's the error we are getting. If we bring it back, okay, now we are getting a different error. Okay, now this is acceptable. At least we know that the indentation isn't the problem. That the problem we are having now in this case is that we've not assigned a value to lowercase o. Alright, we only defined uppercase o here. We've not assigned a value lowercase o. So if I want to also loop through the o, then it means under this indentation I can set another for loop, say for o in the uppercase o. Alright, and then this will produce an error if I don't indent the part I want it to be under the third for loop. So if we try this, this gives us an error because it's not indented. So I'll need to indent this statement under that. That's when we would have this working. Okay, and bear in mind the print statement. I mean, I can actually position the print anywhere, as in based on any of the indentations, and that would determine what will be produced. Okay, but at least there should be one line that's indented under the o. Now if I place this print under the indentation of this for loop, it means whilst we are going through the o, it wouldn't print till it gets to the final value of o. So for every n, every m, and the final value of o, that's when this will be printed out. So you have the values of all the n's, all the m's, but the o is only when o is the final value, which is the 2. If I should just shift the print to the first indentation, then it means I only need the indentation for I only need a print when the n values are varying, but the m should be the very last value, the o also the very last value. So if I run this, I expect to see that the n value will be changing. That's the 2 and the 4, but then the m would be the very final one. The o would also be the very final one. Okay, so like I said, positioning any of the actions, within your loop or outside the loop would determine what your output is. So you should know exactly what you want to get and then how you want to achieve that. Okay. All right. And then we also have what we call the loop control. So we have, I'll be talking about just a few of them. We have what we call the break, the continue, the pass, the else. So let's say we have this. Let's go back to the while statement. I have I being, say, 0. And I have here while I is greater or equal to 0, print I, and then I increase the I in steps of 1. Okay, now if I run this, the very first item of I will be 0. 0 is definitely equal to 0, so this will be executed. From there, I is always going to be positive, and so if I is always positive, then it means this criteria is always going to be true. Alright, so the loop would never end. So we'll have the loop continuing on and on and on. Like I told you, we have that story, so it means it's still going on. It would never stop. And so we'd definitely want to pass in here a control. All right, and so that's where any of these controls come in handy. All right. So let's say I'm going to make use of the break statement. The break will definitely break out of the loop once another given criteria is met. So I have here. So while I is less than, while I is greater or equal to 0, it should be printing. But then I can pass in here another decisioning that if I is greater than 10, it should break. Okay. And we saw this from yesterday. So we are going to be increasing I, but then we don't want I to go beyond 10. So I'm saying when we get to I being greater than 10, it should break out of the loop. And then this becomes a control structure in the loop. So we have I being 0 all the way till it gets to the 10 and then it breaks. But then the reason why we have the 11 showing, bear in mind we said over here, it starts from I of 0. This is 0, so definitely it will print the I. Okay. Then it would move on, increase the, this is actually still, this is still true, so this wouldn't break. Then it will increase the I into step of 1. It will continue. Let's assume now I gets to 10. So it prints the I of 10. It compares this. So 10 is definitely not greater than 10. 10 is equal to 10. 10 is not greater than 10. So this wouldn't break out here. It would increase the I to 11. Now, this condition is true because 11 is still greater than 0. So it's going to print the 11. Before now, it compares the 11 to 10. And once 11 is greater than 10, then we can break out of the loop. And that's why we have the 11 showing. Okay. So whatever you do within your code, based on your output, you should be able to explain and know that, okay, this is the reason why this is happening and how to augment it. Okay. So we have some extra information on the break. So we have an example here. We have a list of names: John, Gideon, Elvis, Grace, Antonia, Rosemary. Okay. And we then make use of the for loop. So the for keyword, and we are saying that for the iterator, which is name, in the sequence of names, if the name is Antonia, then we should print out, okay, Antonia, I have found her. Okay. And then it should break out of it. So this is going to continue because we are going to have the iterator looping through the sequence. So it starts from John. Okay. John is definitely not Antonia, so we don't expect any print. It goes to Gideon. Gideon is not Antonia, so nothing. Elvis, not. Grace, not. When it gets to Antonia, then it prints out, I found Antonia, then it breaks out. Okay. And that will definitely break out of the loop. Okay. Now, let's even make it, maybe we are not seeing the break here, but let's pass in here print statement so that it's better to see how the break works. Okay, so yeah, we have print here. So we are printing the names. So for all the names, we'll still get to print them, but we would only break when the name is Antonia. So it's printed. So Antonia's name will be printed Antonia, I found her, and then it breaks. So every other name beyond Antonia, we don't expect it to, function. So if you run this, you see it starts from John, moves on to Gideon, moves on to Elvis, Grace, and then when it got to Antonia, because Antonia is met, now it prints out what we have here. Antonia, I found her. Then it breaks out of the loop. So the name beyond Antonia doesn't become functional. Okay, and that's how the break works. And so we can make use of also the break statement in the trial question we had that was on the prime number example. So for instance, in this case, where we got the count increasing. So I don't want to increase once I have a first factor. I know this is definitely not a prime number, so I don't need to keep, you know, getting the factors on or the count increasing based on the factors, because that's also some memory usage. So once the count changes from 0 to 1, I just want to break out. So I have this within this modulus comparison part. If the modulus is definitely 0, that means it is divisible. Then the count should increase to 1, and once the count increases, I can break. All right. Or even in this case, okay, yeah, I think let me just leave it at that. So that's it. So it will just break once this one, I mean, it's divisible by a factor. And so this is one of the ways we can use the break even in the while loop. Okay. And we also have what we call the continue. Now this is slightly different from the while loop. Now this actually means when we get to the particular item we are working at, okay, or the particular item we are looking at, it shouldn't break out. It should rather continue beyond that. So let's say we have this example. We have the CTR being 0, and then we are saying for CTR in a range of 10, that means from 0 all the way to 9, okay, because range of 10 will produce values from 0 to 9. And then in this case, oh, I don't even need the CTR plus 1, okay. All right, so we are starting from 0 all the way to 9, and then we are saying that if CTR is equal to 5, it should print the 5 is skipped, right? And then it should continue beyond that. So we can run this. I mean, the rest are just print statements. So it started from CTR being 0, it prints out the value of 0. CTR being 1, it prints out the 1. CTR being 2, it prints out the 2. CTR being 3, it prints the 3. CTR being 4, it prints the 4. Now when you go to CTR being 5, because we are saying here that if the CTR is equal to 5, it should print this statement and then continue. All right. Now that's because we've given a print statement. Imagine we just had a continue. It means it's going to skip that part and move on to the next one. It's going to continue just from the next one. Okay, so unlike the break, which will break at that particular condition, for the continue, when it gets to that particular item or the condition you've stated, it would skip that condition, and that's all. It will skip that particular item, and that's typically what we see from here. Okay, and so that's the difference between the continue and then the break. And then we also have the pass statement. The pass is actually I call this a go-to. If you want to test any of your structures or your syntaxes and you're not too sure of, you can just use the pass. The pass would actually do nothing. Pass does nothing at all. Okay, so let's say, and I use this a lot when I'm trying to check for some trials and exceptions, which maybe we might be looking at those ones towards the end. So let's say I have this um, for say I in range 3. Now the action is just to pass. Now it wouldn't do anything, okay, even though this is iterating through 0 all the way to 2, but because of the pass there's no action defined. We just told it to pass. I mean, nothing at all is lost. Okay, so if you look at this other example, you're saying that x is, say, Kweku. We've assigned the value Kweku to x. Now if x is equal to Ama, it should just pass. Okay, and that's all. We'll be coming back to, we'll look at the functions in a bit, but not now. I mean, when we get there. So let me skip this. So I mean, nothing at all will be done. Okay, exactly. Even if I should say if this is Kweku, then we expect an action because this condition is true, but because of the pass there's nothing produced. All right, that's it. And we have another example. So over here we are saying we've defined a list of numbers from 1 to 10, not in any particular order. They actually um, just randomized, not sorted. And we're saying that for every number in the sequence of numbers, if that number we have at any particular point is divisible, sorry, is not divisible by 2, okay, if the number is not divisible by 2, then it means the number is definitely not even. So we then indicate, I mean, a pass, and we skip that. Else we indicate that the number is, I mean, we just print out the number. Okay, all right. I mean, I think the comments here are wrong, so we skip those ones. All right. So we expect this to only function when we have odd numbers, that this will be printed. Okay. Oh, sorry. I mean, okay, we are saying if the number, the modulus of the number is not equal to 0. Yeah, so okay, yeah, that's true. If it's not equal to 0, that means the odd parts. Okay, so if the number is not equal to 0, that means these are criteria for odd ones. So if it's odd, then we pass. If it's even, we print the number. So for instance, we have the first number being 1. Now we compare 1 mod 2. 1 mod 2 will give us a value of 1, and that one is not equal to 0. So the remainder is not equal to 0. And so that's an odd number. So we just would pass. There's no action here. We pass. And then we move on to the next one, which is 2. Now 2 mod 2 gives us 0. Okay. So definitely this part is a false statement. We can say 0 is not equal to 0. That will be false. So if that is false, this won't be executed. It goes to the alternate, which is the else part. And so it prints out the number 2. And it goes on to the 4. Now this is not true, so it moves to the alternate and prints the 4. So for all the even ones, this criteria is not true, so it prints out the alternate, and that's it. Right? So that's also one way of using the pass control structure. And then we also have the else, which I've already explained one of that. So we looked at this in the decision making. We also saw an example of it up there. So I have my while loop, and then define maybe over here dictionary of menu. So let's say salad, what it contains, potato. Well, these might be right or no. So the essence is just on knowing the code and how it works. And we have a while true. Um, Whenever we have this while true, it means we want to have a seamless sort of unending loop. Because definitely it's just a boolean we are using as a comparison, so it's going to remain true. It's going to be a continuous loop. So you can use this. Let's say if you are programming a device, or you are building um, an application that you want to continuously run, okay, until a certain action has been done that breaks out of, I mean, that particular application. This is one of the ways to go. So while true, now we pick a certain menu option based on the input, and whatever the person enters, if the menu choice is none, if the person passes in the value none, then we break out of it. Okay. And then there's also an alternate, another if condition, not an alternate, another if condition, that if the menu choice that the person entered is in the menu. Okay. So if that menu choice, so we are comparing the menu the person selected to the menu list we are having. So if this menu choice is in the menu, then we can actually, we saw this get method for the dictionary. We can get the menu choice from that menu dictionary and then assign that to the variable food and print out the food. If it's not within it, then it means we just will print out we don't have the particular menu choice. So if I run this out and let's say the user passes in the value of none, then we expect nothing to be done because it's going to break out of it. Okay. Now if the user enters, let's say we have salad. Okay. Now we expect that it produces vitamin, and then the input is produced again. And like we said, this input is produced because of the while true. So there's going to be an endless loop. Okay. So if I keep getting the right options, let's say potato, this would never stop. It will still be asking me, right? Now, if I enter something that is not existent there, so let's say, let's say a bar. Okay, it says we don't have a bar, but it's still continuous because still while true. It only breaks when the choice is none. All right. So if we then want this to break out, we type in our none, and then definitely breaks out, and that's it. All right. So over here we made use of the break, the decision making, the endless loop, and then also the else control structure. Okay. And you can also make use of the continue and then the pass, and that should work very well. Okay. So if there's any question, I think we have just some few minutes, a little over 30 minutes to look at the next part. So if there's any question, I'll address them now before we move on to the next part. So please, any questions? So, Quicken, do you have any questions from your end?
No, please.
Oh, okay. All right. Okay. So, then again, like I indicated from yesterday, the notebooks are also available on the GitHub page, so you can always get access to them and then try them on your own. I mean, that's how you learn to program. Okay, so let's try them out. Okay, so we also look at functions. Now, um, yes, please go ahead.
Yeah, please, I want to ask that maybe after the second if statement, maybe the person entered the right food, which is in their menu, and after the print state, before the print statement, no, after the print statement, you change maybe, okay, it's okay.
All right, okay, sure.
I thought maybe you initialize the true statement with maybe a particular variable, so like maybe you can change that variable to false in order
Oh,
for it
no,
to
no, no, I
break
didn't.
the.
Yes. So I didn't. That's why we made use of the break to, I mean, to break out of the loop once the person, chooses, let's say, none, right? But
Okay.
I mean, since we know our menu choice is a string, I mean, input will always produce strings. You can also create it in such a way that once the user doesn't enter any input at all, it is it breaks out of the loop. At least we know that the length of nothing in that particular um, input would definitely be, I mean, zero. We'll have a length of zero.
Yeah.
So I can just produce that on, I mean, based on the length. Okay. All right.
Okay, thank
Sure.
you.
All right. Okay. So any other question, please, before we move on? Okay. All right. So I think we can move on. All right. There are no questions from my end too, so we are good to go. All right. So now, when we talk of functions, now there are certain actions that you don't want to. I mean, you get to do them almost virtually every time. So you want to, have something that when you call, it just, I mean, performs the action. It goes through the whole procedure for you. You don't need to repeat it. So let's think of it this way. I mean, we have the sign function. So if you remember, I mean, the basic, let's say even our commas that we did, you are given, for instance, the equilateral triangle, and then you are told, okay, the angles are all 60, 60, 60, and then we split it into two, and then you're like, okay, I'm trying to find sine 60, and then you are given certain values, and you need to compute, I mean, through certain processes, right? Now, that whole process, if the I mean that's it's going to be the same for sine of any angle. All right, so if I want to compute the sine of any angle, I'd have to go through that whole process again. So rather than going through the process, I decide to build a function for it so that the function houses the process, and then whenever I perform that same activity on a different input, it knows, okay, these are the steps I need to go through and then produce that output. Okay, so that's where functions come in very handy, so that it stops repetition. Okay, you don't get to repeat, lines of codes and then actions all throughout. Okay, so that's the basic essence of functions. And then functions, the usefulness of functions is that they reduce the size of your code, they save you time for typing, and then they also make it easier to change your program later. And then they make your code also very clearer and cleaner, and then they become more readable. Okay, you see people having, sometimes, I mean, they tell you they have millions of lines of codes, and you look at them and you're like, I mean, even functions can make this way simple, because you see a whole lot of duplications of the same activity. And then also they make your codes very manageable. Now in Python, the default way of writing a function is that you have the keyword def. That means you are defining the function, or you are building the function. So the def is the keyword, followed by the function name. Now the function should be given a name, and then after the function name, bear in mind the function is a method, so it comes with the brackets. We open and we close, and then we have here arguments. So the arguments are the dummy arguments. Now these arguments are not the true values. They are only representations, or they are like representations, or what we call placeholders. They are like empty boxes that are representing what the real value can be. So we have our arguments passed in there, and then this is also a construct. So we have the colon at the end, and then after that, every other thing is indented under that particular function. So we have in here certain actions or certain statements, and then there's always the need to have the return if you want to output from your function. If you want your function to produce to return something out or feed the user with an output, then over here we would need to use the return keyword. Okay, and that's what we've also structured in this image if you look at it. And so that's very easy. Now let's take a simple example. So let's say we want to have a function that finds the um, we want to have a function that would probably just raise whatever number we give, okay, to a power of say 2. It will just square it. So we have def, which is the keyword, and then the function name, which is, let's call this squares. Okay, so def the keyword, the function name squares, and then we open and close the parenthesis, and we have our colon at the end. Now we need to pass in here dummy arguments. So let's say our dummy arguments in this case is say n. N can be anything. All right, after the colon we enter, and the beauty of Jupyter Notebook, once you get to the colon and you enter, it indents for you, right? And then we would want to have, let's say, a certain action. We have n to the power 2, all right? And I can decide to assign this to a variable before returning. I can also decide to just return, if this is my final value, I just return the n to the power of 2, right? Now this is a function that we've built. So if we run this, even though we have the return, bear in mind this is only building more like a blank function, okay? And it would only work when we now call the function and apply it on an actual value. So now we want to make use of this function, the square, so we can then call the function by the name, all right? And then apply it to say a value. Let's say you're finding the square of 5. This gives us 25. Okay, I want to find the square of say 78. It gives me the square value. All right, now if I were to be writing a code, ideally I would have been writing something like this. So maybe, okay, print 5 2, I mean print, so 78 star star 2, say print whatever it is. Okay, now these are multiple lines, all right? So as multiple lines, they are definitely going to take, I mean, some huge time to also compute. They will also waste some memory, right? But once I build it as a function, it's very easy to call the function, and I mean just pass in whatever item I want, and it's good to go. All right. I can also just maybe iterate through a certain list or any data type of some elements, and then just apply the function on them. All right, and that works very, very simple. Okay, so we have also here another function which we call the welcome. Okay, so we have the def keyword always telling us we are building a function, and then the function name is what we call the welcome, and then we have the open and close parenthesis. Now in here we don't need any argument, so this function, we are saying that the function here doesn't depend on any argument. All right, and then we have the colon at the end, and then whenever we call this function, we are expecting that it would have, hello, you are welcome to PY4CA. Let me make this OneQuantum Ghana. So let's say, hello, you are welcome to OneQuantum Ghana. And then this is assigned, this string is assigned to the variable C. And then we return the variable C. So if I call the function welcome, I just expect it to print out, hello, you are welcome to OneQuantum Ghana. Okay, and we are good to go. We also have this function which is just finding the sums of two elements or two entries. So we have def, which is a function. We are telling the program that we are going to build a function, and then we want the function to be named sum of nums, and then the function should always take two arguments. All right, we are using the a and b to represent the arguments it should take. So the function should always take two arguments. That it can be anything that represents a and b, and from there it should add the a and b to produce a c and then return that c. So now if we run this function name, which is the sum of nums, on say the value 2 3, we should expect that that will produce the sum of 2 and 3, which is 5. If you do same for 30, 20, we expect it to produce 50. Okay. Now, what if I enter multiple entries, more than the argument I have, say sum of nums 1, 2, 3. Now, this is a type error because it's telling us that the function sum of nums only takes two positional arguments, but then we gave three, right? So if it's multiple, then I mean, would be facing some challenges. So the real entry should always align with um, they should align with the dummy arguments we produce. Okay, so let's say we have this. Let's try something else. Let's say we have 1, 2, 3. Let's say we have 6, 5, 7. Okay. Now I'm expecting that this should have given us additions, but then the moment we are doing this, we bring the plus sign between two lists. It's telling the system that we are only appending. So what we did here, it's worked. I mean, the function worked, but then it's because the string, I mean, the list understands this plus sign as a way of just appending the list together and getting a bigger list, and that's all. Right? So we need to understand the function, how it's built, what it works with, and all that. So right here we also, yes, yes, please,
Yeah, please, you see when you are calling the function, the welcome function, you just type the welcome and you brought the brackets.
yes,
But using some editors, you have to, because you said return over there, but you didn't use print.
mm-hmm.
They'll tell you to print the welcome before the output, I mean, the return statement in the function. So I want to know what causes that.
I didn't fully get the question. If maybe you can
Is it
reiterate.
when inside the welcome function,
Mm-hmm.
after defining C in the welcome function, you said return C.
Mm-hmm.
And when you're calling the function, you said welcome, and you're able to get the output.
Exactly.
By using some editors, they'll tell you to print the welcome before they will output the hello, you are welcome to Quantum Ghana. Because you said return C, but suppose maybe you just use print C there.
Mm-hmm.
It would have
Okay.
given you the
No, so I think I get your question now. So is this, we set print as an output. So if I should pass here print and say welcome to OneQuantum Ghana. Okay. Now, this print definitely knows I'm outputting to a console, all right, or to a terminal. So even though I've built this function, because of the print here, it will definitely output that onto a terminal. So if I call the function even without the return, because of the print, I expect it to present something, all right. Now, the other option we used was that we did a variable assignment. Okay, so we assign the string to a variable C and we return that variable. So if I'm returning C, it means I'm returning what C contains. So I mean, I wouldn't necessarily need to print the C before I return the C. Okay, so I mean that's how it works. I haven't probably come across an editor that works the other way though.
hello. Because I tried that in PyCharm. I just typed welcome and I brought the bracket. It told me this one, your process finished with exit code of 0. But I didn't get the outcome, hello, you are welcome to one quantum Ghana.
Oh, okay. So maybe after the session, I'll look at it for you so that we can be sure it's not the editor. Maybe it could be that uh, it could be a process thing, or it could be a little typo somewhere. So we can still get a chance to look at it after the
Okay.
session.
Okay.
All right.
Thank
Okay. All right. So we also have another example here, which we call the power function. So we build the function using the def, and then we call the function name power, and then we give it two entries or two inputs. Okay, so a and b, and we are saying that whenever we pass in a and b, it should raise a to the power b, all right, and then assign it to I. So we said the double star means exponentiation, so it should raise a to the power b, assign it to the variable I, and then return I. So if I now call the function on, I call the function in which is the power on the actual values of x and y, where x is 2, y is 3, would have 2 to the power 3, producing the value of 8. Okay, so if I then call the same power on say 25 2, okay, I expect this to produce 625. Okay, so maybe say 95 2, I expect this to give us something around 900. Is it 9025? Yeah, sort of. Okay, so that's typically how the function works. Now, we also have what we call the global and then the local variables when it comes to the functions. Okay, so for instance, in this case, what we are having here, x and y. Okay, these are global variables because we can use them any part of the code. Okay, but then the dummy arguments we created within the function, those dummy arguments are only accessible within the function. They can be accessed outside the function. You get it? So the ones that are accessible within the function are the local variables. They are only locally available to the function. But then the ones that are external, which can be still called into the function, are the global variables. So so that's by way of global and then the local variables. So let's try, for instance, in this case, we've built a function. We've only defined x and y, which are global variables. We have the function, um, what's the name, a and b, and then we have I to be equal to a star star b, and then return I. Okay, let me not return in this case so that we can see exactly what this would produce. So by this, I'm not expecting any output, okay, because I'm not returning anything. But then the moment I decide to print the a, which is in this case a local variable, but it's not accessible outside. Bear in mind, I'm printing it outside the function because it's not indented within the function. All right. Now, okay, sorry, I think I have the A is from a different cell I've run. So let me use something else I haven't worked with today. Let's see the value, say P. Okay, I haven't used the keyword P. So let's say we are now building this on P and B. And then we'd want to return P. Now, this is telling us that the P, there's a name error because P is not defined, right? Because what we are calling is not a global variable. It's not outside the function. It's within the function. So if I'm printing out P, I don't expect anything to show. But bear in mind, if I were to be printing out P here, okay, it means that any value I assign the P would be printed out from the function when I call it, because it's only a local variable and it's only accessible to the function. But then if I decide to print out the external variables, which are the global ones, say x, I should have an output. Okay. And what if I decide to now print the x within the function? Okay. It still gets printed because this is a global variable. So even though it's external, we can still call that within the function because it's a global variable. Okay. And it's accessible anywhere within your code. And that's what makes the difference, treating local variables and then global variables when it comes to functions. All right. And okay, and so we also have another simple function we are building here. So let's say I have this is just a simple potential temperature function, and then what this means is that we are trying to estimate the potential temperature given, let's say if we know the temperature, um, we know the temperature, we are given a reference pressure, we also know the pressure at the next point, and then we are raising all to a power of 0.286. So we are building this function. We start with the keyword def, and then we bring in the function name. Now in this case, I'm building a potential temperature function. So this potential temperature becomes a function name. And bear in mind, as a function name, I can't place spaces between them. Okay, just as it is for variable names. So it's either you're using an underscore or you're merging them together, or you are maybe using uppercase to represent them. But you don't make use of spaces in variable names, function names. You don't use the dash because Python also, as much as it is, I mean, Python is just like any other programming language. It understands this as a subtraction, and so you can use the dash. Right, so we have potential temperature as a function name, and then we pass in here the variables we need. Now, what we are having here potential temperature is dependent on T, P naught, and then P1. So we indicate the dummy argument T, P naught, and then P1, right? And then we have a colon. And then we indent the next part, which is the execution part. And all we are saying is that based on the equation we've been given, multiply the temperature by the P naught over P1. Now bear in mind, if I fail to bring the brackets, if I fail to bring the parentheses, we said Python uses the Pemdas approach. Okay, so we'll start with parentheses. Now there's no parentheses, so we'll skip. We'll move to the exponentiation. Now, by way of exponentiation, it would raise the p to the power 0.286. And that would mean we're already getting an error because we want to raise what's in here, the division we do. We want to raise that value rather to a power. Okay? Yes, Adam.
Yeah, please, someone is asking on YouTube whether you can show a full screen. I don't know
Oh, sorry.
what's
Yes, I
that
think.
means.
Yes, I think I stopped sharing the thing. All right. Okay, so that's been resolved. Okay, so we have this. Um, so we are building the potential temperature function. Let me go over for the sake of those I couldn't share with. So we have the def keyword, okay, and then the function we are building, its name being the potential temperature, and then we have in here the dummy argument. Now the dummy arguments are the dependable arguments we have for the function. So if you look at this, theta is dependent on the t, p naught, and p1. Okay, and then this, which we term the alpha value, actually is a constant, so we have 0.286. So I then pass my the independent variables in here, which is the t, p naught, and p1, and then followed by the colon. And from there, I have my executable part, or the function itself being executed. And I'm saying that Python works by the Pemdas approach. So if Python is working by the Pemdas approach, the first thing it will look out for is parentheses. If there's no parentheses, it will move on to the exponential. Then from there, it would move to the multiplication, division, addition, and then the subtraction. Okay. So if I have this, ideally my function should be this way, right? Because we are looking at dividing p naught by p1 before we raise it to a power. And I'm saying if I fail to do that, what Python would do is that it's going to, because this is the exponential, okay, it takes the p1 alone and raises that to a power of 0.286. And then from there, the next will be the multiplication. So we'll then multiply the t by the p naught and then divide the two ends, okay? And we already know that if we do that, we are going to get a wrong output. Okay, so let's assume this is what we are going to do, which is different from what the real question is, okay? And we return our answer. Now we then test the potential temperature function on a temperature value of say 28, a p naught of say 1000, a p1 of 750, and then it's giving us something else, okay? Now if we bring in the parenthesis, which is to tell us exactly which part is to be handled first. So first we know we are dividing, then we raise to a power, and then multiply by the t. Okay, so then we expect something like this. Okay, now this is within range, so we know this is quite close. Okay, and this is a good representation. Even though theoretically, when we go back into the theory of what potential temperature is, would be able to argue this out. But from a programming perspective, this is what we should get because of the parentheses we placed in at the right place. Okay, all right, and so that's how to simply build this function. Now, like I was saying, theoretically this would also not be right because we would then need to, based on theory, we would need to first convert the temperature from degrees Celsius. If this is in degrees Celsius, we need to convert it to Kelvin and then compute this and then later subtract back into the degrees Celsius. So we can also build a function. If I have that in mind, I can build a function in such a way that it will be dependent on some decision. So the user would pass in the independent variables and then also pass in maybe a particular unit. And then I can use that unit for a condition, which I'll then use that to say, okay, if the user enters a value in Kelvin, then just straight away perform this function and then later subtract and give the value in degrees Celsius or keep the value in Kelvin. And if the user enters a unit of, say, Celsius, then it means I have to convert it, run the function, reconvert, and then produce the answer. All right, so you can look at a merger of a whole lot of things. All right, and that's how useful the function is. Also, we can grow the function by, dealing with conditions. So there's a classical example of what I said. So where the user, after passing in the independent variables, the user can pass in, you can also allow the user to enter maybe say units. And if the user enters a unit and we check, because users are different, somebody can enter a unit in lowercase, uppercase. So from what we did yesterday, the upper method of a string, because we are needing a string as a unit, the upper method of the string unit will change this to a string. So if the user enters C, whether lower C, upper C, and we find the upper of it and it is C, or what the user entered, we find the upper of it and it is Celsius, then it means we can just go ahead and then, you know, convert to Kelvin, run the function, and then, run the action part, and then subtract the value again um, to have the answer back in degrees Celsius. But if the user passes in the value K or say Kelvin, then it means we can just straight away perform the action, and then when we are done, because we've assigned it in both cases of the decision, the output variable is answer, we can just return answer. All right, and so this answer would only be dependent on which of the conditions or which of the decision parts is used. All right, so if we now run this function, so let's say the same value we had, 28,750, yes, and then in Celsius. So if we run this, it means the actual value in this potential temperature conversion is actually going to be 53.8 degrees Celsius. Okay, and that's, we know this is within range because the theories will tell you that is true. Also, like I said, we can loop through a function, so we can have a merger of functions, iterations, decisions. So the first part we saw decision and then function. We can also do iteration and function. So in this case, we build a test function dependent on variables x, the maximum x, and then the x interval. And then we are saying that while the x value you specified is less than the maximum x, right, we should print out the x, and then our x should be increased based on the interval. And then when it's done, we also finally at the end we want it to return the x value at the end. Okay, so we test this on 250 and 2. The function name is test, so we call test on 250 and 2. And because of the print, it's going to print all the iteration parts, but the return will produce just the final one, which is the final x we had. Okay, exactly. So just to, just for you to know that it's possible to merge functions with iterations, with decisions, and the rest. Okay, I believe this will be more the very final thing because we have just some few minutes. Now, we also have spoken about code refactoring from yesterday, where we saw the one-liner decision making as a means of refactoring the code. Similarly, we can also have a one-liner function code refactoring approach, which is using the lambda expression. And so what we'll do is that I indicate first the function or the expression name, and I equate it to the keyword lambda. All right, so the keyword lambda, and then I would specify the argument, and then the colon would follow the argument before the execution or the action comes, which is slightly different from the function we're building at first. So at first we had def, then the function name, and then the arguments will be passed into the parentheses, and then the colon. And then from there we would have the action, and we'll return, if there is an output, we'll return the output. But then in this lambda case, we rather have the function name being equated to the keyword lambda. Then we would have a space and then the arguments. So if there are a certain number of dummy arguments, you can specify all of them, followed by the colon. And then we'll then have here the action. And we don't need a return because it's sort of understands this, that we are building using the lambda expression this function. So whenever I call the function, if there's an output that should be produced, it will produce the output. So with the same squares method we did using the first type of function build, now we are going to build the same squares function. So let's say we have square, which is a function name, being equal to, then the keyword lambda has to come, then the space. Then our dummy argument here is just one argument, which is x, and then the colon. And then we are raising x to the power 2, which is the action. So if we build this, it means wherever we have an input, raise that input to a power of 2, and then when we call that function, return that value that we pass into the function to us. So the same way as we call the first function, the function name, and then we pass the actual argument in place of the dummy argument, we are going to do the same thing. So the function name here is square. We open the brackets or the parentheses, and then we pass in the actual value. And so if the value here is 5, 5 would replace the x, and then it would find the x squared, which is 5 squared, and produce 25. Okay. So what if I have, let's say we are going to perform the same sum of nums. Okay. So we have the sum of numbers, then we call our lambda, and then our dummy arguments say we have x, y, and then z, and then the colon. Okay. And then we are only going to sum them up. Okay. We just use a very simple example. So x plus y plus z. Okay. And that's the whole function. Now we want to call the function that's a sum of numbers on actual values of, say, 1, 1, 1. That produces 3. Say 1, 10, 11. It produces the output. Okay. So um, if it comes to function build, sometimes it's very easy using this. Now this is just one line to build a function. Memory wise, we'll use less memory because it has just a few lines. Unlike the other aspects of function builds, okay, which every line will probably be registered on the PC memory separately, or even if it's using batch like I explained yesterday, they'll all be batched together before they are then sort of executed. All right. And so that's by way of lambda functions. If there's any question, I'll take them because that's the very final part. There's an example here where we tried looking at how to visualize within a function, but we've not done package importation. So we'll do that hopefully tomorrow. And then once we do that, you'll be able to understand what this cell is also um, doing. Okay. But I mean, we just can see what the outputs would be. Okay. All right. So we can just run a visualization also within a function. Okay, so as a way of recap, at least today we've looked at the iterations, we looked at the loop controls or the iteration controls. We also dealt with functions in Python, and then finally we looked at the lambda functions or lambda expressions. And that is the end for today. If there's any question, I'll take those questions before we leave. So any question, please. If there's any question, you can type them in the chat, or you can show by hand, or move to the spotlight and let's interact. So is there any question? All right, so I assume there's no question. We can, okay, yeah, I think there's one in the chat. So okay, I think that's the question. I doubt. Okay, all right. So if there's no question, we'll probably end today's session here. I think I'll hand over to Dorcas, and then my job here is done. So, Dorcas, over to you.
All right, please. Thank you so much, Dr. Jeff, for another wonderful section today as well. We want to thank our participants also for joining in. Those on Gather Town, those on YouTube, any other platform you are joining us from, we want to thank you so much. We really appreciate your time.
Okay, I think we lost Dorcas a bit, but it's just a way of, appreciating you all for the time here. And so, like I said, let me just quickly share my screen so that at least. So, like I said from the beginning, when you go to the info tab, there's an info board that's on the bottom right. You can click on that, and then it gives you some, pinned. Within the pinned messages, we have the link to the various GitHub repository, and then also um, the video that's being streamed. So I know some people would have loved to be part, they would have loved to join, but then they couldn't register on time. So it's possible you can also share the resources with them so that they can still follow from wherever they are. And yes, I think that's just by way of it. I don't know if Dorcas is back and she would want to conclude. Dorcas, are you back? Okay, I think Melvin has a question from the YouTube page. So he's saying with the nested while loop, let's say you want to classify different types of items, okay? How do you go about it? Okay, so I think what we can do is um, Melvin, maybe you can join the gather page because I think there's still room to join. You can join now, and then I would probably take you through that. And those who are also willing to join can still stay. And same as Emanuela too with your question. And I think that's all. So hopefully we meet tomorrow same time and have a wonderful day. Bye bye.
Please. Thank you so much, Dr. Jeff, for another wonderful section today as well. We want to thank our participants also for joining in. Those on any other platform you are joining us from, we want to thank you so much.
Okay, I think we lost Dorcas a bit, but it's just a way of, I mean, appreciating you all for the time here. And so, like I said, let me just quickly share my screen so that at least. So, like I said from the beginning, when you go to the info tab, there's an info board that's on the bottom right. You can click on that, and then it gives you some, pinned. I mean, within the pinned messages, we have the link to the various GitHub repository, and then also um, the video that's being streamed. So I know some people would have loved to be part, they would have loved to join, but then they couldn't register on time. So I mean, it's possible you can also share the resources with them so that they can still follow from wherever they are. And yes, I think that's just by way of it. I don't know if Dorcas is back and she